recording this for those who are missing. Okay. So we know about the atmosphere, which is the sphere of the air surrounding the world. We know about the hydrosphere, the sphere with all the water, including the water that's in the atmosphere, right? So lithosphere. What do you think that litho means? Anybody know what litho means?
The ground.
It means rock. Rock. Have you ever seen a lithograph? A lithograph is a piece of art that was drawn by, natural rock sources, kind of things. Lithographs, but they're really pretty. All right, and so we'll be looking at the Earth as well. So at the beginning, I was looking at Aaron's book to help me to understand what the notes are. I think at first you're just going to listen. In fact, the first part where it talks about rocks, we're going to skip that and go now below that. We'll talk about the Earth first, the parts of the Earth, and then we'll come back to rocks, okay? All right, so you can see right here, we believe what the Earth, the structure of the Earth is something like this. I will tell you, we have not been very deep into our Earth, so we don't know for sure what it's like on the inside. Isn't that interesting? The planet on which we live, we don't know about the structure of it down deep. We sit there and talk about what's in the middle of the moon and other planets. We don't even know what's in the middle of our planet, so we don't know any of that, okay? But we can make some guesses.
What's the middle of the moon? What's the middle of the moon?
I don't know what they tell us. I think they say it's solid basalt rock, but how do we know that? And that there's water trapped underneath there. How do they know that? I don't know. All right, so we think that the inner core is solid, and we believe that is the case because it's under immense pressure. And anytime something gets put under immense pressure, it can be pushed into a solid no matter what. We also think because that is being pushed so hard there that it's probably also very hot. We also think that it's probably made of something metal, a solid metal, and the reason we believe that is because there is a magnetic part of the Earth. The Earth has giant poles on it, South Pole, North Pole, because it's magnetic. It's a giant magnet. And so a metal would help to explain that. Then we have the outer core, which we believe is liquid, still under a lot of pressure and still very hot. And then we have the mantle, which is a little more stiff. We're going to talk about those specifics today. The mantle we've seen because it comes out of volcanoes as lava. And then the crust of the Earth is this very thin outer part, the part on which we live. We have not been able to dig past anywhere in the crust, even the thin parts of the crust. We can't dig past there. So we just don't have the ability to do that. All right, let's watch a little video. Not yet, exactly. Uh-oh.
That it is made up of various zones. The Earth is approximately 8,000 miles or 13,000 kilometers in diameter, from the North Pole to the South Pole. At the center, we have what we call the inner core. It is thought to be a solid metal ball, about 750 miles or 1,200 kilometers thick. This center core is under extreme pressure and is believed to be at least 5,000 degrees Fahrenheit or 2,760 degrees Celsius. Surrounding the inner core is the outer core. This area is about 1,400 miles or 2,300 kilometers thick and is believed to be molten or liquid rock. Nickel and iron are probably the main elements of the outer core. Next is the mantle, approximately 1,800 miles or 2,900 kilometers thick. Geologists think that most of the mantle is solid rock. However, towards the top of this layer, there exists an area of hot, thick, molten rock. This area is called the asthenosphere. And above this area is the cool and rigid outer shell of the Earth, which we call the crust. Geologists sometimes refer to the crust and the solid area directly below it as the lithosphere. As we take a closer look at our diagram, we see that on dry land, the crust is a mere 20 to 60 miles or 30 to 100 kilometers thick. The rock that is similar to the common rock, granite, makes up most of this section of the crust. And under the ocean, the crust is a much thinner layer of rocky material similar to basalt. This section of the crust is approximately 3 to 6 miles or 5 to 10 kilometers thick.
All right. The biggest hole is just a sinkhole. So if we think about the Earth like an apple, We know that there's the core in the middle, so we'd see where the seeds are right there. Then that's kind of hard part that we don't eat. We throw that part out of the apple right there. That would be our outer core. The flesh of the apple would be our mantle, and look at the skin of the apple. That's about how thin the crust of the earth is compared to the rest of the structure of the earth. About as thin as that apple skin. So the thickness varies of the crust varies between 55 miles to 12 miles. That video said a little differently. Does that say continental crust? Okay, 12 miles. He said, didn't he say between 6 to 12 miles at the underneath the ocean? Yeah, I thought it was closer to 6.
6.
Yeah, yeah. So there is a. We're going to talk about the Kola super deep borehole, which is the deepest we have drilled into the Earth's crust. We have dug a mere 7.6 miles. This happened in Russia. I'll show you a couple pictures in a minute. All right. So the outside layer is the crust. It is solid rock, and like we said, it's between 55 and 12 miles. All right. So this is getting ideas of different things around the world. Okay, so for instance, our tallest mountain, 8.9 kilometers. We have a mine that goes 3.9 kilometers down there. The Marianas Trench, which is the deepest place on the earth, is down in the ocean. It's a big trench underneath the ocean. Only goes about 10.9 kilometers deep. Oh, look, there's a Titanic sunken on the bottom of the ocean right there. Yeah. And yeah, sorry about that. We have dug down here to about 12.3 kilometers deep. That's 7 point whatever miles right there. So the idea here is that we want to try to get through the crust. When I was growing up, it was always the farthest down we had dug was 1 mile. That was it, 1 mile. We hadn't gotten any deeper. But then as my kids were young, I remember hearing about this Kola super deep borehole. Now some people say, well, why haven't we dug down any deeper? Well, think about it. What do you have to do to dig down through the crust? I need a giant drill. Okay, so think about a drill, even a really, really big drill. If it's 7 miles long drill, I mean, my goodness, that's going to be tough to do. So this is the place where it was dug. It's in Russia somewhere. I believe the communists were attempting to be the first to dig through the crust of the earth. So they picked a spot that was a little thinner. So it was away from the mountains. You can see kind of how flat it is right here. I would think it would be close to where it meets the sea, where the sea is, because that's going to be the thinnest part of the continental crust. If we go beneath the sea, we can get to the thinnest part of the oceanic crust, but we have all that water above us, so it's just as difficult to try to dig there. This right here is the hole that's covering, I think it's about that big. So we had a drill that went down, and they had to keep replacing the drill bits for it. Oh, I thought I had a video about it. Okay, I don't have a video about it. But here's what I'll tell you, is that as they were digging down, it was getting to the point where the drill bit would melt, because it was the friction of that, and then of course it's getting warmer down there. Now when I was a young adult, I was told that this hole, that you could hear screaming coming from the bottom of the hole, that they put microphones down there, and they heard screaming, so they had discovered hell, and these were the people in hell screaming. And of course, being the scientific person that I am, I said, how did that microphone not melt? So I'm being very skeptical about the whole thing. So they've decided since that time, there were noises coming from there, but they've decided it's the creaking of the rock beneath the earth that was making sort of these funny noises. So I don't believe they found hell. So I don't know that it could be under Russia. I don't know where. Who knows? All right, so when we look at the whole earth, you can see right here, this is the continental crust over here on the right where the mountains are. And you can see underneath here it says the continental lithosphere. So that's all rock. And see how thick that is. It's so thick that it sticks up above the water. It's made of the type of rock known as granite. In the video he said granite-like stuff. There can be some cracks in here. You can see right here where some of that magma will seep up through the continental crust and have volcanic action and make new volcanic mountains, things like this. But also notice right in the middle, we can have volcanoes grow right out of the middle of the ocean. So oftentimes, like for instance, I have a student who told me this morning that she's going to be gone for 3 weeks in Hawaii. And I said, oh, it's going to be rough, Hawaii is in the middle of the ocean, and what happened was there was volcanic action under the ocean, and it's spitting out this new material, building up this, mountain until it finally reached above the waves, above the water. And so it ended up with this, as the earth moved, the hot spot moved, and there's a string of islands out there in Hawaii with eight big islands and then some smaller islands. All right, So you can see what's going on here. So this is called, so Hawaii came out over what is known as a hot spot in the ocean and built it up. In fact, the tallest mountain in the world is not Mount Everest, it's Mauna Loa. No, it's Mauna Kea in Hawaii if you count everything down beneath the surface of the ocean. It's much bigger than Mount Everest. So how about that? Yeah, pretty cool. So what's happening though is that the Earth is a certain size, and as this lava moves up through these hot spots, it'll start to push away those plates. So in the video, it mentioned that this part right here was solid rock, and then it got kind of melty right up here into something called the asthenosphere. That's theory. We don't know that for sure. How do we figure it out? We figure it out by, in fact, one of the favorite things for earth scientists is when there's an earthquake. You might think, why would anybody be happy about an earthquake? Well, because when an earthquake happens, it sends these waves all the way through the Earth's surface, and those guys can study it, and they can see waves travel through solid rock differently than they travel through liquid. And so you can see those waves on an instrument that picks up that kind of thing, and you can tell about what's happening beneath there. So they like to get the data from an earthquake. But why is an earthquake happening? It's happening because as this gets pushed down, as the crust of the Earth gets pushed away from these new mountains forming over here, it has to go somewhere. Okay, the whole world doesn't just keep getting bigger and bigger. It stays the same size, and so instead of growing upward, it plunges downward like this. All right, and then when it gets down here, guess what happens? It gets real hot and it melts into the asthenosphere, or turns back into a solid, or something like that. And I think we're going to cover this stuff right here in more detail either next week. You can look at the book, I guess, or in a future module. Yeah, next week we're gonna do plate tectonics, earthquakes, and volcanoes. So we'll get into much more detail then. Okay, but seeing all this, you can see that we have rock forming here into this new volcano right here, and then we have rock melting down here that's forming new rock. And so we're going to see there are 3 types of rocks. You should know this already, and this is going to be your top blanks of your page. Okay, in your top blanks of your page right there, there are 3 main types of rock: igneous, sedimentary, and metamorphic. All right, so what you're going to write is igneous is rock that forms from molten rock or lava. You can say volcanoes, rocks that come from volcanoes. For sedimentary, you're going to write rock formed when chemical reactions cement sediments together, hardening them. That's a lot of work. How about sedimentary is rock formed from being laid down by water deposition. It takes sediments and lays it in a new place. Heavy water over the top causes it to harden, becomes new rock. And metamorphic is igneous or sedimentary rock that's been changed into a new kind of rock due to great pressure and temperature. You already knew these 3 kinds of rocks, I suspect. We studied these in general science. I think y'all all took general science with me. So we studied all these. In fact, my general science class is studying rocks tomorrow. Rocks and minerals. So this is one of those things you need to know the rest of your life, right? For Jeopardy. Yeah. Okay, we ready? You're writing all the words?
Yeah.
Metamorphic means to change, right? Metamorphosize, yeah. So, here we go. If we see some metamorphic rock like this, they're formed when minerals and rocks are changed underground, typically by heat and pressure. Igneous rocks are created when magma cools, becomes solid. I've got a couple different kinds to show you. And sedimentary is rocks that have been laid down by water. Sediments are laid down. All right, we have something to watch here. Let's see. Can't remember.
Rocks are everywhere. They are large and small, heavy or light, porous or dense. But rocks in some shape or form can be found all over the planet. Different types of rocks are formed in different ways. There are 3 main types of rock: igneous, sedimentary, and metamorphic. Igneous is a word that means fiery. Igneous rock is formed when magma or lava cools. Sometimes magma cools slowly underneath the Earth's surface. This forms intrusive igneous rock, like granite. Other times, lava cools when it comes to the surface in a volcanic eruption. This forms extrusive igneous rock. Some examples of extrusive igneous rock are tuff, obsidian, and pumice. Igneous rocks make up about 95% of the Earth's crust. The next type of rock is sedimentary rock. Sediment is small particles of sand, mud, and organic material that settle to the bottom of water or land areas, often lakes or oceans. Sedimentary rocks are formed when sediment accumulates over time in deposits that form layers. These layers become squeezed and compressed over time until they consolidate into a rock. Sedimentary rocks are the types of rocks in which fossils may be found, since the process of forming sedimentary rocks can preserve plant and animal remains that are deposited into the sediment layers. Some examples of sedimentary rock are limestone, shale, and sandstone. The third type of rock is metamorphic rock. The word metamorph means to change form, and metamorphic rock is rock that has been changed by extreme heat and pressure. Sedimentary rock, igneous rock, or even other metamorphic rocks can be changed by heat and pressure into new kinds of rock. Metamorphic rocks can be formed by being deep under the earth where pressure and temperatures are high, or when rock near the surface is heated up by the movement of tectonic plates or magma. Different types of rocks become different types of metamorphic rock when exposed to heat and pressure. For example, shale becomes slate. Sandstone becomes quartzite. And limestone becomes marble. Rocks are slowly but constantly changing in something known as the rock cycle. The rock cycle begins with magma, or hot melted rock, deep beneath the Earth's surface. This magma becomes crystallized, becoming igneous rock. These rocks begin to erode or break down into small pieces because of wind, water, or other forces. The small fragments of rock are carried away as sediment when water passes over them, and are deposited in layers, which eventually become sedimentary rocks. Then, some sedimentary rocks are pushed below the surface due to tectonic activity, where they are exposed to heat and pressure, transforming them into metamorphic rocks. If the rocks are buried even deeper, they may melt and form magma, starting the cycle all over again. Of course, sedimentary and metamorphic rocks can be eroded into sediment, and igneous rock can become metamorphic rock or lava. But one way or another, rocks all over the world keep changing from one form to the next.
All right, there we go. So what's the difference between rocks and minerals? Does your book ask you that, or am I just adding this? Okay, it turns out that minerals are the building blocks of rocks. All right, so 2 or more minerals make up rocks. For instance, granite includes quartz, feldspar, and mica. And those can also be found in sandstone, feldspars, and mica's in gneiss. That rock right there is called gneiss. Yeah, pronounced that way. So therefore, the difference is that minerals make up rocks. So we have rock. Granite is made up of quartz, feldspar, and they're saying this stuff called biotite here. And the elements would be quartz, would be silicon and oxygen for making quartz. Okay, so the building blocks of rocks are minerals. All right, directly under the crust of the earth is a mantle. We only know about it from indirect observation. That's when I told you earlier, when earthquakes occur, seismographs measure those waves coming through there, and we can analyze those to see if it looks like they're going through solid, going through liquid, this kind of thing. Because waves travel through different substances with different speeds. That's going to be part of our lab today. By analyzing these waves, there was a guy, here's his name, ready? Andrija Mohorovic. So found that the miles below the surface of the crust, a big change takes place. Now, since his name is kind of hard to pronounce, we just call him Mr. Moho. Okay, Mr. Moho. And what we call this area now is called the Moho discontinuity. All right, the Moho discontinuity. So what happens is, I think we're going to get to a picture of that, but let me tell you this real quick. Yeah, that when sound is traveling through stuff, right now my sound of my voice is traveling through the air, and it's going to your ear, and your ear is vibrating, and your brain is interpreting the sounds I'm making. And it turns out that like here, the distance we're going to travel, it's the slowest. Sound going through gas or air is the slowest way for it to travel. Okay, it goes much more quickly in water. You probably noticed this if you're in a pool and you go underwater and you can hear some sounds pretty distinctly under there. Of course, our ears are designed to hear sound in air, so we hear the best in air. But you can hear sounds underwater, but it actually goes the best through a solid. So this is that deal if you're trapped in a building and you need help. Instead of yelling, start banging on something metal. They'll find you more quickly that way because sound travels through solid. And we're going to test that for lab today. All right, what is the MOHO? Okay, so the MOHO is a boundary between the crust, right here is oceanic crust, continental crust, and the mantle right here. So there's this different stuff. So the sound waves travel differently through there. And so we can see right here, this discontinuity, we can see that the waves are traveling. A P wave is a type of wave that comes from an earthquake. And as the P wave was traveling through the crust, it went a certain type of a wave. And then it changed a lot, and then it went through the mantle, which is why we think it's probably solid there. And so the energy came in here and the wave came out here. So it allowed us to see there was this difference in there. So we think that that MOHO is just a difference. It's almost like a boundary between a liquid and a solid. So just below the MOHO, right there at the MOHO, the upper mantle appears to be solid rock, according to these waves that are passing through. It's thought to be under lots of pressure, temperature about 1,000 degrees. That's known as the lithosphere. Just below the lithosphere is something called the asthenosphere. We'll see a little video in a minute on there, where the rock is liquidy, but not quite rock. It's rock. Think of a rock. It's hard, right? If we melted it, it would turn to liquid, yes? Well, hey, darling. Come on in. And so that's what we're looking at. We're looking at a liquid type of a rock. All right, we're going to also try to show you that in lab today, okay? We call that plastic rock. Is that something you're supposed to fill in a blank? What is plastic rock? Look at your book.
Yes.
Okay,
Wait.
all right. Rock that behaves like something between a liquid and a solid, okay? We call it a non-Newtonian liquid, a non-Newtonian liquid. It doesn't act like most liquids, and like I said, our lab is going to show us what this is. Okay, so what are we looking at here? This is what we call the plastic asthenosphere. It's kind of a weird word, plastic asthenosphere. It's liquefied rock. All right, so the lithosphere includes the crust. The MOHO is probably right there between the lithosphere and the asthenosphere. And then we get to what's known as the upper mantle. All right, so if we go down, let's start at the top. We have the crust. Then we hit this thing called the MOHO, which is the boundary between the crust and the mantle. The lithosphere, the asthenosphere. Okay, did I put the MOHO in the wrong place then? That means the MOHO's up here. I thought it was below the lithosphere. The asthenosphere, the mantle, mostly silica, which is hard, one giant sand grain, right? Then we hit the Gutenberg discontinuity. That's another guy who was researching those waves going through the Earth, and he found another boundary between the mantle and the outer core, which is why we came up with the idea of there being an outer core. We think it is mostly molten iron. Then we have the Lehman discontinuity between the outer core and the inner core. We believe that that's why we separated those from an inner core to outer core. The inner core we believe is solid. All right, now mind you, we really don't know any of this. We're just guessing. Okay, so here it is. Oh, good. I like to see that the MOHO was put in there. Okay, the crust, the MOHO, the upper mantle. Look what they're calling it, the lithosphere, including the upper mantle. Then our asthenosphere. Then the lower mantle, semi-rigid. That seems to contradict something, doesn't it? I gotta go back, okay? Doesn't that change our asthenosphere and mantle? Yeah. Okay, let's watch our video. See if it helps to explain it. This might not be the video. Oh, it is.
What are the lithosphere and the asthenosphere? The outer rigid unit of the Earth covers the entire surface of the Earth and consists of the uppermost mantle and crust. The upper part of the mantle is cooler and more rigid than the deep mantle and in many ways acts like the overlying crust. This rigid unit of rock is identified as the lithosphere. The lithosphere tends to be thinnest under the oceans and in volcanically active continental areas such as the western United States. The average thickness of the lithosphere is measured approximately 50 miles or 80 kilometers. Scientists believe that below the lithosphere there is a relatively narrow, mobile zone in the mantle called the asthenosphere. This zone is composed of hot, semi-solid material, which can often soften and flow after being subjected to high temperatures and pressure over geologic time. The rigid lithosphere is thought to float or move about on the slowly flowing asthenosphere. With the discovery of the asthenosphere, geologists are better able to explain the theory of plate tectonics,
Which we'll learn about next week. The plates floating on top of the plastic rock of the asthenosphere. All right, so this is pressure freezing. Are you supposed to write this down? Pressure freezing is when the force of pressure makes a liquid turn into a solid.
Like that oobleck stuff when you put.
We're gonna make that. Yeah. All right, so we're going to see that today. Here's a guy running across it. Okay, that's just the way that cornstarch tends to act. All right, we're ready for lab. So what we're going to do, first thing we're going to do in our lab is we're going to test how sound travels. Okay, so what I have for that is, can you hand out goggles to everyone, please? Then I need that bucket, so I need all the goggles out of there. This is different than what the book has suggested. We're doing it a little differently because it's easier this way. So what I have for y'all are stethoscopes.
Wait, so the layer, it says which layer is of the Earth's core undergrowth pressure freezing?
Say it again.
Which layer of the Earth's core undergrowth pressure freezing?
Oh, we think the core. The core.
Oh, because it's hard.
It's really, it's totally, and so if we were able to release that
Inner
pressure,
core
it wouldn't
or
be
the outer
solid
core?
anymore.
The inner core, the outer core.
I think the inner core is what the note said. Okay, so I'm gonna need that. Yeah. Okay. Will you hold on to it? Hold on to it. Let's just erase it. And just kind of pull it into. Okay, now we can take it to the table. Okay, so y'all are gonna come up, so put your goggles on and you're gonna come up here. Now you're gonna be working with a partner. We're gonna need this water for other stuff, but, okay, so what you're gonna do,
in there.
what's in there?
No.
Okay, so one of you starts with the, y'all grab the stethoscope right there. And so you're gonna listen, and Aaron, you're gonna clank these like this, and you're gonna listen to it. And then you're gonna put it down in here, and you're gonna, and see which one you hear better. Okay, so you do that. You could do it for the girls too if you wanted to over here. So yeah, hold it up, no, just like that. Can you hear it?
Wait, no.
Okay, tell me this, can you hear this? Okay. Well, don't do that.
I heard that.
Okay, just clank them together. Alright, now put it against the side. And now you go in and put both spoons inside there. Do you hear it better? Yeah?
Yeah, it's
You think it was better? Okay, let Erin try. Do you wanna clean those off from her ears?
so weird. Period. I want to hear somebody's heartbeat now.
You can listen to your heartbeat.
Where? Okay. No, where's the heartbeat?
So I cleaned that one off like right before we started, so. Okay, so Lily, go ahead and clean those next to there.
Go further down.
You hear it?
Ow.
Okay, now put it against the side. Spoons in the water.
Oh, it was definitely
Louder, right? Yeah. Okay, Lily, your turn. Except the other way.
Can you hear it?
She's not as new as you, Erin. Okay, hold it up against the side.
Can you hear it?
Oh,
wait,
Are you about
wait,
to
stop.
sound straight to the beginning? Okay, ready?
Can't really
I'm sorry.
Okay, I'm coming. Okay, you went. I was like, oh yeah.
So now here's this, the sound travels through the water better. Do you get it? Okay, now is this? What is that sound?
Build layer
No,
of the
you're
earth.
not gonna do that. I
I
have
so
it.
just X this out.
Well, you're actually gonna write that about the ear, seeing. So I had some students make this, a little, or model right here, very nice, young person. And then they had made it from the inside out, but we're gonna have to start over. Okay, hold that.
Dental floss. Remember when we did that?
Yeah, so y'all have already done this essentially.
For reals?
Mm-hmm.
I don't remember.
Not in this class.
Okay.
You see the line, is it right there? Right there. Okay, so I'm just gonna pull this through.
She's breaking the earth.
There we go. And you see the core and the mantle and the crust. I thought that was better on that side. Right, that might have been from your brother's class. Yeah, so you would have done it in an earlier class, all right. But this shows you the model, so if you put the little thing of clay, then the bigger thing of clay. Okay, so what I think I want you to do on this part right here is to, what does that say, procedure 1? Conclusion 1, okay. This, we're fixing to do this. So on this right here, draw a line down the middle of your page right here, and on here you're gonna say, sound travels better through liquid than through air. And then draw the picture of this and the stethoscope and say what you did with the spoons and all that.
Wait, right, what? Where?
So on this side, instead of this, you're gonna write sound travels better through liquid than through air. Alright, and now I think we'll go to this table. And time for lab coat. Get messy. Do you want a lab coat? Sure. The dirty one is mine.
Well loved.
Indeed. Here's the clean one. Any other person wants to use this?
I know, but you stole it from me.
Dawn on the first day, she was like, I got toilets. She was so
I think,
excited.
I didn't give it to you because I just forgot. I'm
This is
sorry.
the only one I know. This is the
The only best I've been making this.
I don't even remember.
Okay, so we're gonna do this.
I'm only wearing lab coats.
Lab coats are actually kind of pricey. So I got for my students aprons.
Yeah,
Y'all wear an
we
apron?
wear aprons.
Yeah, they were like that. They're cheaper, although they were not that cheap. Spend some moolah.
That's what you want?
say what you did. The procedure is clank spoons in the air, clank spoons in the water. I want you at the very bottom, draw this tank and draw the little spoons and the little stethoscope, you know. And go ahead and grab the spoons. And an empty cup. There's a beaker over there with a handle on it.
You want the beaker or the
The
cup?
beaker's good. Let's do the beaker. Okay, y'all, so what I have here, y'all done this before. What did you call it, Zoe? I'm gonna make some of that.
Can I hear it?
Or do you want to get up? Here, wait.
Back
Wait.
is yours.
Here, do you want to rub it on the alcohol?
So this can get messy, but fortunately, the last time I did this on the other campus, we lost them.
Bestie in lunch. I'm late. Okay. I wanna hear. That's so cool. Look. Oh, well. Check each other's pulse.
I'm just listening to my heart beat.
Yeah, it goes 1 and 2 and 3 and 4 and 2 and 3 and 4
Okay, let's see if this is good or not good enough.
Now you know how my innocent ears felt.
Okay, so y'all come on up
How
here.
it would feel.
It was loud.
Okay, so this is, remember pressure freezing, y'all can come up. You two. So put your hand out. And when I give it to you, squeeze it like a ball, okay? Squeeze it. And now, relax.
Ooh, I want some dough.
Thank you. We're gonna try to limit our mess.
It won't bite you, Trisha.
Huh?
It won't bite you. Are you sure? Wait, what are we supposed to do?
Hold it over something, maybe this one. Maybe we're done with that bar. Okay, so hold it, when you hold it like this, it's gonna be solid. Okay, that's pressure, you take it, Aaron. And then when you let go of it, notice it's not solid anymore.
It becomes cushy.
Okay? Right, it becomes kind of this, so it's not really a liquid,
So
it's
this
not
is
a
what,
solid.
so this is what plastic growth looks
Yes, except it's really, really hot.
like. Oh.
Okay, so now you can see it down here in the bowl right here. So if I let it go in there, I can, if I hit it hard like that, it's like I hit the top of it, but if I put my finger down in really slowly, I can go right down to the
That's
bottom.
the same. Oh,
You see?
so
But if I do this one, like that. So this is what we think. Now, the reason why cornstarch does this, it's kind of interesting. We don't really know why cornstarch does this, except that its pieces are really, really, really small, like clay, and they sit next to each other. Oh, look at, Zoe's got a nice little
Waterfall.
column forming there, yeah. So they say that if you have enough of this, you can put it like in a kid's pool, you know,
And run on top.
and then run on top of it.
Oh,
I've
it's
seen it on
right.
TV before. It just would take a whole lot of cornstarch. You see, so that's definitely liquid, isn't it?
Oh.
Is this like how quicksand is, and then if you try to even up?
That's an interesting question because I'm not exactly sure what quicksand is. I know this at my church we're putting in a new parking lot, and when the guys came and took the old parking lot out, they underneath, did you know this? Where those holes are? There was you put your hand like this and it was like this. So the whole ground was like a little trampoline. And the guys put in and said, we don't know what to do, so they had to dig down in there. It turns out there was a layer of mud like this, and it was causing the parking lot area to be very soft, and then they put new stuff over it, it'd be kind of like a sinkhole. You heard of a sinkhole? It would open up underneath it, and you could sink down in. So you parked at church, you come out, and your car's like down in the hole.
So we're basically on a sinkhole.
Well, so they just had to dig. They were small. They were very small. Yeah.
Yeah, small.
I'm trying to keep mine really hard.
Do you want to make
Now it will dry out.
It will? When?
Well, because every time you're touching it, some of that liquid's coming out of there. you know.
Yeah, and then
Are we gonna make a big
And
one?
then it'll just turn into. So
Okay.
actually, it's kind of easy to clean up because it just turns back into cornstarch.
It will turn back into cornstarch?
Yeah, pretty much. Once it gets all dehydrated, see, it's cornstarch again right here.
So if you put this into food, it needs to cook with it.
Hey, in fact, you know what, why do we do this in food?
So
Do you know why we
it
add
thickens
corn?
it up.
It thickens it up. This is why it does it. It thickens it up. So you put a little bit in water and you pour it into your soup, right? And the soup gets thicker that way. Yeah.
So what was it back in the days where like there was famine? What was cornstarch?
Well, it comes from corn. So they didn't know about it till after 1492, right? Because they didn't discover corn till the New World. But now corn does tons and tons of stuff, tons and tons of cool stuff. Including
I just
great
realized-
science experiments. It's really dry.
I am definitely gonna have to do this with little girls as well.
Oh, nice. Now, is it still
Oh my
melting?
goodness, it's so sticky. Can I wash
Yeah.
my hands?
Yeah, I think we can just wash our hands right here in this bucket. I don't think we need this from me.
That's cold.
That's bizarre.
It is so strange, yeah.
I don't think I'm
So remember, it's called a non-Newtonian liquid. So it's not acting like most liquids act.
Bigger.
Alright, now what you're gonna need to do is to write this up and talk about what is plastic rock, and you can say that cornstarch tends to act like plastic rock. Hey, yeah, could you go get a couple of paper towels? And just, I don't see any in my room, or spray for that matter. I haven't cleaned any table after any class today.
It's okay, none of us are gonna have COVID.
I can use clean alcohol this afternoon.
If our family catches COVID, we already have a plan that another family of ours, we're just gonna quarantine together.
Together?
Yeah, it's funny because because the other family's like a group of boys and we're like a group of girls. So I was thinking, yeah. It's just like, okay, we're just gonna live with each other for 2 weeks.
I was about to say, it's only 2 weeks, yeah. And furthermore, you probably won't even get sick. You're gonna have to work on stuff. But I definitely had some students out this week. They didn't have it. Somebody had it.
Look at this. Like, look at that.
Wait, do you think I can make this, Anne?
That might
From this to the
be
trash
more
can?
like-
I don't know, probably.
Alright, so now what needs to happen, and maybe you could bring the trash in, or you can get all this in the trash.
There's a little bit on the floor over here.
Yeah, and then, if we let it dry, we can sweep it up. If it doesn't get enough smashed into it. Okay, and before we're done, y'all we're gonna look at all the rocks before we leave.
Okay.
We go.
Different kinds of rocks.
Definitely gonna need this for little girls.
Oh, and it's so easy.
Oh, yeah.
And if you use the water, and you put food coloring in the water.
Wait.
It moves, but
Wait, did you put the cornstarch in the water?
Yes.
Did.
So I did, the cornstarch was powdered.
Oh,
I added
so
water
it's
to it.
the-
Oh, no, I didn't.
the way
I
it
just put
is.
the trash.
okay.
So it flows.
Ah!
It's very strange.
It's really cool Play-Doh though.
Yeah, if you put it in a Ziploc bag, it'll last a little longer.